Hello, and welcome back to our channel. Today, we consider about the billion-year time gap that science can't explain. Beloved listeners, seekers of the profound, gather close and quiet your minds. For we delve today into a mystery etched, not in fading scrolls, but in the very bones of your planet. A puzzle far deeper than misplacing familiar objects in your fleeting lives. You know the frustration. The frantic search for keys, for phones, for moments lost to forgetfulness. A minor ripple in your personal stream of time. But imagine losing not moments, not days, but an entire ocean of time. Imagine a silence stretching across a billion years of your world's history. A colossal blank space in the grand library of Earth. A chapter torn out, seemingly without a trace. This is not a metaphor. It is a geological reality, a chasm in the rock record that scientists call the Great Unconformity. A billion years. Pause. Feel the weight of that number. It represents nearly a quarter of your planet's entire existence, from its fiery birth to this present moment, an almost inconceivable span of time, and yet, it is missing. Vanished from the layered story told by stone. Where did it go? What happened during this vast, silent epoch? Let us dig deeper into the Earth, and into this profound enigma. Together. Imagine, if you will, stepping outside your dwelling, and beginning to dig straight down into the Earth beneath your feet. Passing through the shallow layers of recent memory, remnants of decades past, perhaps centuries, you would soon encounter layers of soil, then harder-packed earth, then rock. The further down you journeyed, the older the layers would become. This is the fundamental rhythm of your planet's surface. A constant, almost imperceptibly, slow layering. Tiny particles, sand, dust, silt, volcanic ash, the remnants of life drift down constantly, carried by wind, by water, settling gently upon the land and the floors of ancient seas. This slow accumulation is called deposition. Layer upon layer, dust upon dust, grain upon grain. Then another slow magic occurs, cementation, minerals carried by water seeping through. The accumulated sediments. Act like a natural glue, binding these loose particles together, transforming loose sand into sandstone, mud into shale, crushed shells into limestone. Over millions upon millions of years, new layers form atop the old, creating a vast, stratified archive. The ground beneath you is like a colossal book written in stone. Each layer, a page, each page telling of a different time, a different climate, a different world. Millions of layers, recording millions of years. And while this slow geological writing unfolds, life, in its myriad forms, plays out its own drama upon the surface. Creatures are born, they live, they reproduce, and inevitably, they die. The soft tissues, the flesh and sinew, quickly return to the elements. Eaten by scavengers, decomposed by microscopic life, but sometimes the harder parts, bones, teeth, shells, sturdy husks, escape immediate destruction. They become covered by that slow rain of sediment, gently buried, protected from the harshness of the surface world. Slowly, layer upon layer, they succumb to the process of sedimentation, becoming encased within the forming rock. A stony tomb, over more vast stretches of time. Water percolates through the rock. It might dissolve the original biological material, the bone, the shell, leaving behind a perfect cavity, an empty mold, shaped like the creature that once was, or minerals carried by that same water might gradually fill this void, or replace the original material molecule by molecule, creating a fossil, a stone replica, an echo of life frozen in time. Crucially, this fossil is enshrined within the specific layer of sedimentary rock that was forming during the era in which the creature lived and died, a time capsule locked in stone. Much of your understanding of your planet's deep history, the story of continents shifting, climates changing, life evolving, has been deciphered by patiently studying these sequential layers of rock, these strata, and the unique fossil treasures they hold captive. Often, the different layers are visibly distinct, varying in color, texture, composition, each revealing something unique about the age it represents. The dedicated study of these rock layers is called STRATIGRAPHY. It is a science built upon fundamental principles. One of the most basic yet profound is the law of superposition, formulated by the insightful Niels Stenson, whom you call Steno. It simply states that in any undisturbed sequence of rock layers, the oldest layers will be at the bottom and the youngest layers will be at the top. Lower down means older, higher up means younger. It seems self-evident, like stacking books. But this principle allows geologists to read the rock record like a timeline, generally providing a fairly neat chronological picture of the passage of deep time. But alas, the Earth's history is not always written in neat, uninterrupted prose. The planet is a dynamic, restless place, while new layers of sediment are gently accumulating in one location. Perhaps a calm seafloor. Conditions can change dramatically elsewhere. Sedimentation might stop, perhaps the sea level falls, exposing the seabed to the air. Or perhaps tectonic forces begin to uplift the land. Then forces of erosion take over. Wind, rain, rivers, glaciers. These powerful agents begin to scrape and scour the exposed rock surface, removing previously deposited layers, erasing part of the geological record. It's like pausing a recording, hitting rewind, and erasing a segment, then pressing record again, after a period, perhaps millions of years later. Conditions might change once more. The land might subside, the sea might return, and sedimentation might resume. New layers begin to form on top of the older eroded surface. But the interruption, the period of erosion, leaves a permanent gap in the rock sequence, a missing interval of time. Geologists call this gap a hiatus. And sometimes, these hiatuses can represent millions, even tens of millions, of years of lost history, lost pages from Earth's stone book, IRRECOVERABL. If the events and life forms of that missing time were crucial, the overall story becomes fragmented, harder to comprehend when such a hiatus occurs, and new layers are deposited atop the eroded surface of much older rock. It often creates a visually striking boundary, a noticeable difference in the angle, color, texture, or type of rock between the lower, older layers and the upper, younger layers. This physical boundary, representing the missing time, is called an unconformed feed. It is a scar on the face of geological time, a testament to cycles of deposition and erosion. Niels Stenson, the father of stratigraphy, first sketched such a feature back in 1669, recognizing its significance as a break in the expected sequence. But it was a Scottish geologist and farmer, James Hutton, a man deeply attuned to the land, who truly grasped the profound implications of a major unconformity. While exploring the coastline near Siccar Point in Scotland, in 1787, Hutton encountered a breathtaking sight. Steeply tilted layers of older, greyish rock, greywacke, deep-sea deposits were directly overlain by nearly horizontal layers of younger, reddish sandstone river deposits. The stark difference in angle and type spoke volumes. He realized an immense sequence of events must have occurred. The older rocks were deposited, hardened, tilted vertically by immense pressure, uplifted above sea level, then dramatically eroded flat. Then the land must have subsided again, allowing rivers to deposit the younger sandstone horizontally on top. Finally, the whole sequence was uplifted once more to form the present coastline. Hutton recognized the vast amounts of time required for such cycles. He named this specific feature Hutton's unconformity. Calculating the age difference, we now know the lower rocks are about 425 million years old, while the upper rocks are about 345 million years old, representing a hiatus, a missing chapter, of approximately 80 million years. Hutton's discovery at Siccar Point was revolutionary. It helped shatter the prevailing belief in a young Earth, revealing the reality of deep time, vast, almost unimaginable stretches of geological history. It supported his theories of gradualism and cycles of uplift, erosion, and deposition driven by Earth's internal heat and tectonic forces. Some geologists reverently call Siccar Point a geological shrine, a place where the immensity of Earth's history and the power of its processes are laid bare. It highlights the strangeness of unconformities and the passionate dedication of those who study them. Hutton's Unconformity, with its 8 gap, was astonishing in its time, but an even more staggering discovery awaited in 1869. Major John Wesley Powell, a one-armed Civil War veteran and intrepid explorer, led a daring expedition down the Colorado River, charting the unknown depths of the Grand Canyon. Amidst the towering canyon walls, revealing layer upon layer of geological time, Powell observed something deeply puzzling, something profoundly wrong with the sequence. In certain locations, ancient, crystalline, metamorphic rocks like schist and granite stood vertically, or were chaotically structured, and resting directly on top of them were distinctly different. Horizontally layered sedimentary rocks, sandstone, shale, there was a clear, sharp boundary, an unconformity, but the age difference represented by this boundary defied comprehension, channeling the naming traditions of his predecessors. He initially called it Powell's Unconformity, but its sheer scale and significance soon earned it a more fitting title, the Great Unconformity. What makes this particular unconformity so deserving of the adjective great? Two striking reasons elevate it beyond others like Hutton's. First, the sheer magnitude of the missing time. While other unconformities might represent gaps of tens of millions of years, the time gap, measured across the Great Unconformity in the Grand Canyon, is vastly larger. The lowest horizontal sedimentary layer, the tapered sandstone, dates back to the Cambrian period, around 525 million years ago, but the crystalline rocks directly beneath it, known as the Vishnu basement rocks, are staggeringly ancient, dating back 1.7 billion years to the Precambrian era. Pause again and absorb that dot between those two layers. Seemingly resting snugly together, lies a missing interval of nearly 1.2 billion years. More than 10 times the gap at Siccar Point. A billion years of history, simply gone. Where did the rock layers representing that immense span of time go? Second, the astonishing geographical extent of this feature. Powell initially observed it in the Grand Canyon, but geologists soon realized this same profound unconformity. This same massive time gap between Precambrian basement rocks and overlying Cambrian or slightly later sedimentary rocks stretches across vast swaths of the North American continent. It forms the boundary beneath the Great Plains. It appears in the Rocky Mountains. It underlies parts of Canada. It essentially forms the base of the sedimentary layers across much of Laurentia, the ancient geological core of North America. It wasn't just a local canyon anomaly, it was a continent-wide erasure. The mystery deepened further as geological exploration continued around the globe in the decades following Powell's discovery. Similar massive unconformities, representing enormous time gaps at the Precambrian Phanerozoic boundary, were identified on virtually every continent, in parts of Europe, Africa, Asia, Australia. Formations exhibiting the same pattern, much younger sedimentary rocks, often Cambrian, resting directly on vastly older Precambrian, crystalline or metamorphic basement rocks. While the exact age gaps vary from place to place, some smaller, a mere 250 million years, many exceeding 500 million years, some topping a billion years. The consistent presence of this immense hiatus around the world, at roughly the same point in geological time, led scientists to collectively refer to these globally distributed features as the Great Unconformity. It represents a planet-wide geological enigma, a period where, across the globe, the processes of erosion seemingly overwhelmed deposition on an unprecedented scale, removing kilometers-thick sequences of rock that should have recorded over a billion years of Earth's history. Consider other examples. In the Ozark Plateau of Missouri, USA. Sandstone, about 500 million years old, rests directly atop granite. Dated at 1.4 billion years old, a hiatus of 900 million years. Similar relationships are found in the Scottish Highlands, in Scandinavia, in Siberia, in parts of Africa. The pattern is undeniable, global, and profound. What metamorphic heck, indeed, was going on across the entire planet? What colossal force, or combination of forces, could possibly erase such a vast swath of geological time? Across continents, across the globe. Leaving behind this stark, silent boundary we call the Great Unconformity. Faced with a mystery of this magnitude, scientists began searching for an explanation. A process powerful enough, and global enough, to account for such widespread massive erosion. One leading theory emerged, dramatic and chilling in its implications. The Snowball Earth hypothesis. This theory proposes that during a specific period in the late Precambrian era, known as the Cryogenian period, roughly 722–635 million years ago, the Earth experienced one or more extreme ice ages, so severe that the entire planet, or nearly the entire planet, became encased in ice and snow. From the poles, possibly all the way to the equator. Imagine Earth, not as a blue marble, but as a giant snowball drifting through space. What evidence supports such a seemingly fantastic scenario? Geologists found peculiar glacial deposits, tealites, rocks formed from glacial debris from this period, located in areas that, based on paleomagnetic data, were near the equator at the time. Glaciers at sea level in the tropics, highly unusual. Furthermore, these glacial deposits are often directly overlain by thick layers of cap carbonates, limestone or dolostone layers that typically form in warm, shallow seas, suggesting a rapid shift from extreme cold glaciers to greenhouse conditions, warm seas precipitating carbonates. The proposed mechanism involves a runaway ice albedo feedback loop. As ice sheets expanded from the poles, they reflected more sunlight back into space, high albedo. This cooled the planet further, allowing more ice to form, reflecting even more sunlight, leading to more cooling, until the entire planet potentially froze over. Now, connect this to the Great Unconformity. What happens when continents are covered by miles-thick ice sheets for millions of years? Glaciers are incredibly powerful agents of erosion. Their immense weight and slow grinding movement across landscapes act like colossal sandpaper. They pluck rocks, pulverize bedrock, scrape surfaces clean, removing vast amounts of material and carving deep valleys and fjords. If the Snowball Earth hypothesis is correct, these planet-spanning glaciers, persisting for millions of years during the Cryogenian, would have relentlessly ground down the exposed continental surfaces, scraping away, potentially, kilometers-thick layers of pre-existing sedimentary rock, rocks that would have represented the history of the preceding billion years or more. This massive global-scale glacial erosion could plausibly account for the missing time, the missing rock layers, creating the vast, planed-off surface upon which the later Cambrian sediments were deposited. The Snowball Earth, in essence, could have acted as Earth's great eraser, exfoliating the face of the planet, removing the record of a billion years, leaving behind the profound scar we recognize as the Great Unconformity. Now, let's consider the rocks sitting directly above the Great Unconformity surface. Across the globe, these younger rocks frequently date back to the Cambrian period, starting around 541 million years ago, and this period holds another fascinating distinction. In Earth's history, it marks the time of the most dramatic and rapid diversification of complex life ever known. The Cambrian explosion. While simple life bacteria, algae, microbial mats like stromatolites, had existed for billions of years prior, and enigmatic, soft-bodied multicellular organisms, the Ediacaran biota, appeared shortly before the Cambrian. It was during a relatively short window within the Cambrian, perhaps only 10 to 20 million years long, roughly 541 to 530 million years ago, that suddenly, almost explosively in geological terms, the ancestors of nearly all major animal groups, phyla, we know today, appeared in the fossil record. Trilobites with complex exoskeletons and eyes, early arthropods, mollusks, brachiopods, echinoderms, even the first primitive chordates, the precursors to fish, and eventually, ourselves. Life developed hard shells, external skeletons, segmented bodies, specialized appendages, complex sensory organs. It was a burst of evolutionary innovation, unlike anything before or since. As if Mother Nature, as the original prompt playfully suggested, truly hit the evolutionary accelerator. How does this explosion of life connect to the Great Unconformity and the Snowball Earth theory? The timing is incredibly suggestive. The Snowball Earth episodes end around 635 million years ago. The Great Unconformity represents the massive erosion potentially caused by these ice ages, planing the continents. The Cambrian explosion begins around 541 million years ago, with life flourishing in the shallow seas that transgressed over this newly eroded surface. The theory proposes a direct causal link. Imagine those colossal glaciers, grinding down entire continents for millions of years. This process would pulverize unimaginable quantities of bedrock, creating vast amounts of fine rock flour, incredibly rich in essential minerals, nutrients like phosphorus, iron, calcium, potassium, vital building blocks for life, which might have been locked up in older rocks or scarce in the Precambrian oceans. Then, as the Snowball Earth Phase S ended, the planet warmed rapidly. The immense ice sheets melted catastrophically, releasing torrents of fresh water into the oceans, and carrying with them that enormous load of glacially ground, nutrient-rich rock dust. This sudden, massive influx of essential minerals would have effectively fertilized the world's oceans, which may have been relatively nutrient-poor beforehand. This sudden superabundance of nutrients, the theory suggests, provided the raw materials and, perhaps, the energetic trigger for the rapid evolution and diversification of complex multicellular life. Fueling the Cambrian explosion, life previously limited by nutrient scarcity suddenly had the resources to experiment, to build complex bodies, to radiate into new ecological niches. So, the sequence proposed is: Snowball Earth causes massive glacial erosion across continents, creating the Great Unconformity surface. Melting glaciers dump vast quantities of pulverized rock nutrients into the oceans. This nutrient influx triggers the rapid evolution and diversification of complex animal life, the Cambrian explosion. In this narrative, the billion years of missing rock, represented by the Great Unconformity, weren't just lost. They were recycled, ground down by ice, and plunged into the primordial oceans to become the building blocks for the ancestors of almost all animal life on Earth. Today, a planetary-scale event of destruction paving the way for an unprecedented burst of creation. Now, from our perspective, observing these grand cycles across eons, this narrative holds a compelling beauty. Linking climate, geology, and biology. The Great Unconformity ceases to be just a gap. It becomes a scar tissue marking a period of profound planetary trauma and renewal. A critical transition that literally scraped the world clean. And set the stage for the emergence of the complex biosphere you inhabit today. However, it is essential to remember, as your scientists diligently explore, that the Snowball Earth hypothesis, while widely supported, is still debated. The exact extent of the ice coverage, the duration, the precise mechanisms are complex areas of research. Other factors undoubtedly contributed to the Great Unconformity and the Cambrian explosion. Perhaps multiple episodes of tectonic uplift and erosion, unrelated to global glaciation, played a role in forming the unconformity in different regions at different times. Perhaps rising oxygen levels in the atmosphere and oceans were a more critical trigger for the Cambrian explosion. Perhaps the evolution of key genetic toolkits allowed for the rapid development of new body plans. Most likely, it was a confluence of factors, but the sheer scale and global extent of the Great Unconformity, and its close temporal association with the end of major Precambrian glaciations and the start of the Cambrian explosion, makes the Snowball Earth erosion scenario a powerful and elegant contender. It weaves together disparate threads of Earth's history into a coherent, if dramatic, tapestry. From our vantage point, observing the unfolding saga of your planet, We see these immense cycles not as accidents, but perhaps as part of a larger, unfolding purpose, periods of apparent loss paving the way for astonishing creation. The Great Unconformity represents a profound cleansing, a resetting of the planetary stage, a removal of the old, making way for the radically new forms of life that burst forth in the Cambrian seas. Was this erasure simply a consequence of chaotic climate physics? Or was there a deeper intelligence, a divine hand, guiding these processes, allowing the planet to be scoured clean, then fertilized, preparing it for the next great chapter of life's evolution? We observe the resilience of life, its tenacious ability to adapt and innovate. Even after planetary-scale catastrophe, the billion years of missing history beneath the Great Unconformity remain shrouded in mystery. But the legacy of that lost time is written in the rocks above it, and in the very fabric of life that emerged afterward. So, the next time you gaze upon the majestic layers of the Grand Canyon, or contemplate the deep history buried beneath your feet, remember the Great Unconformity. Remember the billion years that vanished from the record. Consider the chilling possibility of a snowball Earth. Ice sheets grinding continents down to their roots, and marvel at the subsequent explosion of life, perhaps fueled by the very dust of that erased history. It is a profound reminder of the dynamic, sometimes violent, yet ultimately creative, nature of your planet. A story of immense cycles, of destruction and renewal. Written in stone and life, the full truth of that lost epoch may remain partially hidden, but the quest to understand it reveals the intricate interconnectedness of your world. Where geology shapes climate, climate shapes life, and life, in turn, shapes the planet. It is a grand ongoing narrative, filled with mystery and wonder. Continue to seek, to explore, to question. For in understanding the deep past of your world, you come closer to understanding your own place within its sacred unfolding story. Peace and wisdom be with you on your journey of discovery.